Okay, here we go. So our homework for tonight is lesson 5. We're in module 6. It starts on page S39 and we're going to start with problem 1. First, I'm going to review things that we talked about in class, and this kind of piggybacks on our lesson that we've been talking about all week, which is kind of cool. So the graph of a function can be used to help describe the relationship between the quantities it represents, which makes sense. I mean, we use graphs so that we can see and have a visual of our data. A linear function has a constant rate of change. A nonlinear function does not have a constant rate of change. A function whose graph has a positive rate of change is an increasing function, and a function whose graph has a negative rate of change is a decreasing function. This makes sense. Let's go back to a linear function. So we talked about linear functions earlier in the year and in science class. A linear function or a linear equation, a linear graph is a straight line, whether it goes like that, or it could go like that, or it could go like that. It's linear, it's straight. So non-linear, non is our key point there. A non-linear graph is something that's not straight. So it could look like this, or it could look like that, or it could, I don't know, be crazy like that. So these are linear because they're straight. These are non-linear because they're not straight. So the rate of change is not constant. Nonlinear graphs do not have constant rate of change. Linear functions do. They have a constant rate of change. So they climb, they go up, our slope is steady, the rate of change is steady. Okay, so now we review that. Let's take a look at our problems. Number 1, read through the following scenarios and match each to its graph. Explain the reasoning behind your choice. So guys, I love these because we can use the process of elimination even if we get stuck. When I'm looking at this problem, it's giving me scenarios, it's giving me information, and I have to look at each of these graphs and determine which graph goes with which scenario. So the cool thing about this one is it gives us 2 graphs on this page, and then the other 2 are on the back page here. So I'm going to look at my 4 scenarios, go ahead and figure out which 2 these go with, and then I'm going to look at the other 2 because I know it'll only be the other 2 options left. They're not trying to trick you here. Each scenario goes with each graph. So this shows the change in a smartphone battery charge as a person uses the phone more frequently. Okay. A child takes a ride on a swing. Okay. A savings account earns simple interest at a constant rate. Okay, there's a keyword. We just talked about constant rate. A baseball has been hit at a Little League game. So we know when we're talking about constant rate, it's straight lines. We just determined that here. Constant rate, linear functions are these here that are straight lines. So when I look at these 2 graphs, I know for sure it's not this one because this one's not linear. It doesn't have a constant rate of change. This one here does. So let's think about that. You have a savings account, and it earns simple interest at a constant rate. So guys, you might be thinking, I don't even have a bank account. I don't know what that means. And you might be going into panic mode. So I'm going to tell you, when you have a savings account, you can earn interest on the amount you have in your savings account, which is what's really cool. So basically, you put this money in the bank, you put it in a savings account, and the bank says, oh, we'll match that interest rate, or we'll give you interest at 0.05%. So for every dollar, you're earning 0.05. Pretty cool. One reason why you want to save money, start a savings account, have a savings account, not just keep it under your mattress. But anyways, so a savings account earns simple interest at a constant rate. So I'm looking here, again, I know that it could be this one because it's a constant rate, it's a linear function. I'm going to look at these other 2 graphs, and oh my gosh, neither of them have a constant rate. This one's not a linear function, and this one's not. Neither of those. So the basic process of elimination, I know for sure it's this one, and it makes sense because if you have a savings account that starts here, and then the money's sitting there and it's just growing and growing at a constant rate, the dollar amount, so the dollars would be here, the dollars are growing as time goes on. So this one matches scenario C. Scenario C. And don't forget, oh, getting a little blurry, I apologize. Let me put my autofocus on. There we go. Don't forget, it says explain the reasoning behind your choice. You guys, I just talked all about it, so I want you to put that in your own words. Make sure you're using complete sentence. You should have a capitalized letter at the beginning, punctuation at the end. Pause the video if you need to, but I'm going to go ahead and move on. So this graph here matches scenario C. Let's look at this next one. This is an interesting graph. We know that it's not a constant rate of change because it's nonlinear. So let's look. This shows the change in a smartphone battery charge as a person uses the phone more frequently. Well, I know the majority of you have a smartphone right in front of you. You might be looking at that instead of listening to me. You might have one in your pocket. If you're in class, hopefully it's in your book bag, put away where it's supposed to be. But anyways, let's think about that. If you were to picture a cell phone battery charge on a graph, you have the charge percentage here, and you have time down here. And you start, hopefully, with 100% charge, but then as time goes on, the charge starts to die. And as you use it, it might die. And it says uses the phone more frequently. So we're looking for a graph that looks like that. It's not going to be this one because it doesn't start up here. So let's see. Oh, looky here. This could be the start of my fully charged cell phone battery, and then as I use it, it drops more frequently. So, scenario A goes with this last one. Okay, so pause the video if you need to, but I'm going to move on. You need to put it in your own words. Remember, it says explain. So use that academic language. Use those key buzzwords we talk about all the time. Constant rate of change, negative, positive, increasing, decreasing, all that good stuff. Let's look at this one and see if we can figure out. A child takes a ride on a swing. Okay, so think about that. When you're riding on a swing, you're going up, you're going down, you're going up, you're going down. You don't just go up once and then come back down. So this one's not really making any sense to me to go up and come down. I mean, that would be, if I did that to my son, if I put him on a swing and I pushed him once and then said, okay, we're done, he would have a meltdown. That's what 2-year-olds do. But anyways, but when I look at this other graph, the swing goes up, the swing goes down, the swing goes up, the swing goes down. You get my point? This one more closely matches it than this one, but let's just double check ourselves. A baseball has been hit at a Little League game. Oh, for those of you who have played baseball or you like to watch baseball, I must say go Giants. But anyways, look at this graph here. When a baseball gets hit, doesn't the baseball go in the air and then eventually drop due to gravity? Right? You seeing it? I know you're picturing that ball going up and down. So we could say that this is the distance, this is the time. Guys, this one's D. It's got to be. Put it in your own words, which leaves me with B, my child on the swing. Makes sense. You should have 4 complete sentences or more than 1 sentence for each of those scenarios because it told us to explain, and we've talked about this, we've talked about it. I need you guys to understand that when it says explain, it's looking for an explanation. It wants to know what your answer is and why you think that's the answer. Okay, so pause the video if you need to, but I'm going to go on to number 2 because I only have 15 minutes in these videos. So again, pause it if you need to, but I'm going to move on. The graph below shows the volume of water for a given creek bed during a 24-hour period. On this particular day, there was wet weather with a period of heavy rain. Ooh, this is getting interesting on us. So the first part here. Describe how each part, A, B, and C of the graph relates to the scenario. So this is the same thing we were looking at earlier in the week when we were looking at those linear functions where it is a straight line. This is the same thing. It's just not, it's not straight. It's not constant. So it's asking, for this part of the graph, the A part, what happened? For this part, what happened? And then for this part, what happened? The cool thing about this one is it's telling us what's happening. We just need to interpret it using the data from the graph into our own words. So, pretty much here, the rain begins, and as rain falls into the creek bed, the volume of the water flowing in the creek bed rises. It's increasing. It's going up. And then if you look at B, a period of heavy rain occurs, and it causes it to rise quicker. It's going up quicker than it was right here. And then C, the heavy rain begins to subside, meaning it begins to fall off. The rain stops, and the volume of the water continues to increase, but not as much. So here it's like starts to rain, heavy downpour, and then it's just kind of sprinkling, drizzling, whatever you want to call it. So again, you need to describe or explain and complete sentences in your own words each part of this graph. And that's it. That's it for number 2. So I'm going to go to number 3. Half-life is the time required for a quantity to fall to half of its value measured at the beginning of the time period. If there are 100 grams of radioactive element to begin with, there will be 50 grams after the first half-life, 25 grams after the second half-life, and so on. Okay, that's a lot of information. So if you need to reread that again to make sense of it, go ahead. But it wants us to sketch a graph that represents the amount of radioactive element left with respect to the number of half-lives that have passed. So if I look at my graph here on my y-axis, going up, y to the sky, I have amount of radioactive element in grams. And then x right here, I have number of half-lives. So I know that it told me here that the quantity is going to fall, and when something falls, it's decreasing. So I know I'm going to start up here, and it says if there are 100 grams of radioactive element to begin with, I know that my graph has to start here. So I'm going to make myself a little note. See, 100 grams, 100 grams. So I have 100 grams to start with. And then number of half-lives, it tells me there will be 50 grams after the first half-life. So if you look here, it tries to trick us. It goes 0 to 2. So my first half-life, number 1 half-life, has to be right in here. And it tells me that it's going to be 50 grams. So my graph, if I find 50, again, it's tricking us. It goes 40, 50, 60. I know that it's going to have to fall to like right there, because at 1, it's at 50. Okay, and then 25 grams after the second half-life. So second half-life is at 25, which is even more tricky because it goes 20 to 40. So 20 to 40, halfway's got to be 30. Halfway's got to be 25 between 20 and 30. So there we go. And so on. So you can see the constant, it's going on at a pretty constant rate. So I can just kind of finish that going like that. Okay. So I did that. I did A. I'm going to put a check mark right there. We sketched the graph. Here it says, is the function represented by the graph linear or nonlinear? Well, it's asking you, is it a straight line or not? No, it is not. Remember, capitalize, period, and it wants you to explain. Okay, so I'm going to give you a minute to put that in your own words. Explain why it is nonlinear. I told you that it's nonlinear, but explain why. And then C, is the function represented by the graph increasing or decreasing? Well, if we started at 100 and it went down, we already talked about how falling is decreasing. So it's decreasing, and I want you to put that in your own words. Okay, and that's it. That's your homework for tonight.